Ever stop to think about what's actually inside your phone? Or, what makes an electric car glide so quietly? Or even those huge wind turbines? Well, today, on the Deep Dives, we're going deep into something fundamental to all that tech, something you likely interact with constantly without a second thought. Rare earth elements. Our mission today. Really unpack what these things are, why they're suddenly so critical, trace their incredibly complex journey from deep in the earth to our devices, and try to make sense of the intense global politics swirling around them. We're looking at a situation where production is massively concentrated, and there's this, global scramble to get access.
That's right. And, rare earths might sound maybe a bit obscure, like something just for scientists, but their impact is massive on tech, on the economy, even national security. We're talking about materials that are quite literally shaping our modern world and, our future.
Okay, so let's start right there. What exactly are these rare earths? And you often hear that word rare. Is that actually accurate?
Good question to kick us off. So, rare earth elements, or REEs, they're a group of 17 metallic elements on the periodic table, and they're absolutely crucial for a whole raft of high-tech stuff. Their main superpower, if you like, is in making these incredibly strong, but also lightweight permanent magnets. These are the engines behind so many motors. We're talking elements like neodymium, praseodymium. They form the core of these supermagnets. Then you add others like dysprosium and terbium, and those allow the magnets to keep working really well even when things get hot, which is vital, for an EV motor spinning fast or inside a huge wind turbine generator. And you picked up on a key point there, the rarity. It's a bit misleading, actually. These elements aren't, geologically speaking, super rare in the Earth's crust. You find them pretty widely distributed. The real challenge is finding them concentrated enough in ore bodies where it's actually economical to mine and process them. It's more about them being dispersed than truly scarce. And where do they end up? Well, everywhere. Looking at the numbers from our sources, something like 29% goes into cars and vehicles, another 16% into wind power, big chunks. Manufacturing uses about 28%, and electronics around 20%. So they're really embedded across the board.
Wow, okay, so it's less about scarcity and more about their unique, almost magical properties. It's kind of mind-bending how much our advanced tech relies on this specific group of 17 elements. They really are, it seems, irreplaceable for a lot of cutting-edge applications. Right, so we've got a handle on what they are and why they're so important. But like you hinted, the story of where they come from, that takes a really unexpected turn. You'd think, given their value, it would be a global free-for-all. But the supply chain, it's dominated by just one country.
Yeah, it's quite stark, really. China's position in the rare earth sector is, overwhelming. Back in 2020, for instance, China mined about 60% of the world's raw rare earth ores. But here's the really crucial part, the bottleneck. China controls somewhere between 85 and 90% of the processing. That's the difficult bit, turning the raw dirt into the usable metals and alloys, especially magnets.
85 to 90%, staggering.
It is. And it wasn't an accident. It's the result of decades of strategic policy, what some sources call China's deep plowing approach. Basically, massive, long-term state investment and subsidies poured into every single step. Low-cost mining, yes, but crucially, mastering the complex refining and processing right up to making the finished magnets. They built the entire ecosystem. One source had this great analogy, the sandwich fillings. Other countries might mine the bread, the raw ore, but China perfected making the valuable fillings the processed materials. That makes competing incredibly tough.
So they hold the keys, essentially, to unlocking the actual value.
Pretty much. You see these massive hubs like Baotou in Inner Mongolia apparently responsible for something like 40% of global rare earth output just by itself. And most of this is managed through, I think, 6 major state-owned enterprises. It's very centralized.
The implications of that level of control over materials essential for, almost everything modern. It's huge, isn't it? You have to ask, though, while China clearly played a very smart long game, were other countries just asleep at the wheel? Maybe too focused on quarterly results to make those long-term bets on processing.
I think that's definitely part of the story. A lack of consistent strategic investment outside China absolutely contributed. It created this vulnerability that many places are now scrambling, really, to fix.
Which brings us to the next big question. If these things are so valuable, so critical, why isn't everyone jumping in? Why aren't there mines and processing plants popping up everywhere? Because the reality is you dig into it involves some, let's say, uncomfortable truths and really high walls.
Exactly. And it comes down to some pretty major hurdles that stop widespread production outside China. First off, the environmental cost is significant. Mining, and especially processing rare earths, is dirty work. It can generate huge volumes of toxic waste like acidic sludge and sometimes even radioactive byproducts from the ores. Managing that safely requires very sophisticated and very expensive environmental controls. Think about trying to separate 17 very similar elements from each other. Chemically, it's complex, resource-intensive stuff.
Okay, so it's messy.
Very. Then you have the economics, just building a new rare earth mine, and particularly the processing facility needed to go with it. It's incredibly capital intensive. We're talking billions, and it takes a long time. You might be looking at maybe even 15 years from planning to actually producing usable material.
15 years. Wow, in tech terms, that's like 3 generations ago.
Right. And on top of that, the market prices for rare earths can be wildly volatile. So investors look at the huge upfront costs, the long delay, the environmental challenges, the price swings. It looks like a very risky bet. So, this really frames the challenge, doesn't it? How do these factors, the environmental damage, the huge cost, the time lag, the technical difficulty, how do they dictate who plays in this market and who doesn't?
That 15-year timeline alone seems like a massive barrier for anyone but maybe state-backed players.
Mm-hmm.
Does it basically lock out smaller companies, or are there, shortcuts emerging given how urgent this feels now?
It's a huge deterrent, absolutely. It heavily favors players with deep pockets and, frankly, strategic patience, which often means government stepping in. Are there shortcuts? Not really for the core challenges. Environmental approvals take time. The chemistry is complex. You can maybe streamline some things, but you can't just wish away the fundamental difficulties or the years it takes to build these complex plants.
Okay, so given those massive challenges and China's dominant position, what are other countries actually doing about it? What's the counter strategy to secure their own supplies?
Well, there's definitely a reaction happening globally. A lot of countries are trying to reduce that dependence. Look at the U.S. The Mountain Pass mine in California is back online and ramping up. It produced, 47,000 tons in 2024, which sounds like a lot, and it is significant.
But compared to China's processing?
Exactly. It's still relatively small compared to China's overall capacity, especially in processing, but it's a start. And the U.S. government is actively trying to fund and encourage more domestic processing capability.
Okay, what about elsewhere? Europe?
Europe's active too. In Germany, you see companies like VW investing in research, particularly around recycling efficiently. There's even talk of a magnetic highway concept for collecting and recycling magnets. France has projects like the Eric Caranaut initiative. Then you've got the UK's Pensana project aiming to build processing capacity. And crucially, Australia's Linus.
Yes, Linus is a big non-Chinese player.
Yeah,
right.
They are. They mine in Australia and do their processing in Malaysia, a really important alternative source. And Japan deserves a mention, too. They were perhaps the first to really feel the pinch back in 2010, and they've been very aggressive since then, both in finding diverse mining sources and really pushing the boundaries of recycling technology, like pulling rare earths out of old air conditioners.
Recycling sounds promising. Is that the silver bullet?
It's definitely part of the solution, but it's not there yet. Currently, recycling provides less than 1% of the global rare earth supply. The challenges are collecting enough old products efficiently and then actually extracting the small amounts of rare earths from complex devices. It's technically hard and often not economic yet.
So still a long way to go on that front.
Yeah. And there's also research into substitutes, trying to design motors or other tech that needs fewer rare earths or none at all. But again, that's more of a long-term research goal for many applications, not an immediate fix.
Okay, all of this activity, this concentration, this scramble, it inevitably leads to the big geopolitical question, doesn't it? This idea of rare earths potentially being used as a weapon.
That concern is definitely out there, and it's not just theoretical. The memory of 2010 is strong when China temporarily restricted exports to Japan during a dispute. That single event sent shockwaves globally and really woke everyone up to the potential leverage China held. It showed how supply could, potentially, be tied to political or economic aims.
A clear warning shot.
Absolutely. But looking at the bigger picture and considering what the sources argue, using rare earths as a sustained weapon might be trickier than it looks. Firstly, it could massively backfire on China itself. Their own huge manufacturing sector relies heavily on readily available rare earths to make the high-tech goods they export. Cutting off supply hurts them too.
Right, they need the inputs for their outputs.
Precisely. Secondly, Any aggressive move like that would pour fuel on the fire of diversification efforts globally. It would make countries double down, triple down on finding alternatives and building non-Chinese supply chains, ultimately weakening China's dominance in the long run. So the argument goes, while it could cause serious short-term disruption, higher prices, project delays, it might not be a decisive, game-changing weapon over the long haul. The market eventually would adapt, albeit painfully. But it absolutely feeds into this much broader critical conversation happening everywhere now about securing supply chains for all sorts of essential minerals, not just rare earths, and linking that directly to national security.
So, stepping back, what does this all tell us about where things are headed for technology, for global power dynamics? What's the main takeaway from this whole complex picture? What strikes me is how these obscure-sounding elements are just fundamentally woven into everything we consider modern, everything we consider future tech, especially clean energy, yet getting them, processing them, it involves these huge environmental trade-offs and creates these really complex geopolitical pressures. It's a real tangle.
It truly is. The whole rare earth situation is a perfect microcosm, really, of this constant tension we see everywhere now. It's a balancing act. You've got the relentless drive for technological progress on one side, the absolute necessity of dealing with the environmental consequences on the other, and layered over all of it are these shifting sands of global power and strategic competition. Innovation, stewardship, power, they're all in the mix.
So let's leave our listeners with something to chew on. Considering how vital rare earths are for green tech EVs, wind turbines, the very things we need for a sustainable future, and knowing the heavy environmental footprint often involved in getting them, how might this global push towards sustainability end up both easing and maybe even intensifying the geopolitical tensions around these absolutely essential materials?